Great presentation, Karen and Lin. Thank you. We have listened to 3 talks about resilience and the capacity measurement. Another important aspect of reliability is to have right SLOs. During the pandemic, Google built a global skill services to help people identify potential COVID exposure. Today, we'll have Marilia and Melo from Google to talk about how to ensure reliability for such a service with a well-defined SLOs. Now, let's welcome Marilia.
Hi everyone, thank you for having me here. I'm at my home today with this bookshelf full of books in Japanese. So don't pay too much attention to it. If you are trying to read the title and you can make it, it's probably because it's in Japanese. So don't worry about that. But I'm here today to talk about defining SLOs for exposure notifications. SLOs are also known as service level objectives. Have you heard about it before? Or are you still wondering why that's important and how it could be related to your working life? Well, look at these examples. Do you remember seeing any news about these systems unavailable recently? Maybe you don't remember any of these examples, but you likely heard about the vaccine scheduling websites crashing as soon as it became available for COVID-19 vaccines recently. Well, if surveys are trying to meet the service level objectives and they're trying to operate at scale, they will likely make it to the news if they are unavailable. If a system is unreliable, it will not be a good system at scale. Reliability is a key feature of any system. Google considered it so important that it created a profession called Site Reliability Engineering. That's my job title. I'm Marilia Melo and I'm a Google SRE. I joined Google almost 10 years ago in the Tokyo office. I was hired just after completing my master's degree in computer science and worked in the Google Japan office for 5 years before moving here to the Bay Area. I have worked at 3 completely different teams inside Google, and prior to working as an SRE, I worked at the cloud support team, where I had first-hand experience of how systems unavailability can have an impact in our external customers. One interesting thing about Google is that it created the SRE job title in 2004, more than 15 years ago. But it actually only created a role called Customer Reliability Engineer in 2017. So the Customer Reliability Engineering team, we work not only with our own reliability, but we also work with external customers in helping them understand the reliability when they operate in the cloud. My team, Customer Reliability Engineer, are Google SREs who focus on customer systems. We engage with customers by doing conduct reliability reviews, build shared monitorings, advise customers preparing for them for critical periods, for example, Black Friday, Cyber Monday, or New Year's, depending if it's a retail customer or a social media customer, for example. We also conduct joint retrospective for incidents, design reviews, and tabletop exercise. It's a very dynamic team, and I really love the work we do. Today, I'm going to share about the work that has been the most impactful and the one that I have been most proud of my entire 10 years career at Google. We are going to talk about the application called Exposure Notification that's used for tracking COVID-19 exposures. Has anyone heard about that application before? I hope so. I hope you have that installed on your phone. But before talking about the application, let's get on the same page about reliability. So reliability is a key feature of the service, and it should be prioritized and worked on, not just taken for granted. Some would actually say that reliability is the most important feature of a system, because if the system is not reliable, if the user cannot use the system, why would they care about any other feature? We know what is reliability, and we know that's probably the most feature of a system. So how can you say if a system is reliable or not? If someone asks you if your system is actually working reliably, how would you answer that? To be able to communicate reliability with others, be inside your own team or company or with external customers, we need to define SLIs and SLOs. Are you familiar with those terms? So SLIs and SLOs give you a common language that can be used to easily understand by any member of the system, from the VPs to the product manager and SREs and software engineers. You may be thinking, oh, come on, Marilia, I already know what is an SLI and SLO. Good, because if you know how important that is, you know that in today's example, by defining correctly, SLOs can help save lives in real life. So just a quick recap on how we actually measure reliability. To calculate the system's availability, you take the number of total interactions and then calculate the fraction of good interactions. This unique way of calculating it helps understand it's just not just a matter of the system is up or down. This very likely is true when working with system at scale, where you likely have more than one service at a time for your application. So in order to start measuring your system's reliability, you need to measure the total interactions and calculate the fraction of good interactions of a server. Once you have that, you actually have an SLI, the service level indicator. Here you have an indicator quantifying the service reliability. Probably the most common representation of an SLI is the number of HTTP requests. If you have 10,000 requests, as example, out of those 9,900 requests were 200, which means successful requests, then your SLI is of 99%. Now, once you have established the way to calculate your SLO, you can set a reliability target. And that will be your service level objective. Easy peasy, right? So pay attention now, because you will understand that how 99% translates into real numbers that affects your daily life. This is the table that actually helps you understand that when defining a reliability level, you're actually at the same time defining how much your application can be down. This is why this table is so important. These tables will help you define the amount of downtime you are willing to tolerate in your system. So for example, let's say that you have the 3.5 nines. This is what we usually represent the 99.95%, which means that for 30 days, your system will be down for 21.6 minutes. So if you have a 10% error rate, that can only continue for 3.6 hours, for example. But remember, in a complex distributed system, it's rarely about being hard down. These numbers are assuming 100% outage as well. But we know that for system at scale, that can be more complex. So now we understand how reliability is important. We know how to measure it, an SLI, and how to communicate that via an SLO. How do you actually apply that to a system that you want to know if it's reliable or not? So here are the steps for you to follow. This is the most important slide of this presentation. If you want to know how to apply SLOs to a system, do these 4 things. 1. Understand the application use case. 2. Identify the critical user journeys, or CUJs. 3. Set up the SLO target. And 4. Measure your SLO and adjust when needed. People often forget how important it is to define the critical user journeys. I will share how doing this wrong can specifically impact your team, especially when we're talking about system at scale. So let's see how we use this in the application used to for contact tracing of COVID-19. If you're not familiar, exposure notifications is a joint effort by Google and Apple to help governments and global communities fight the pandemic through digital contact tracing using iOS and Android mobile devices. So when mobiles are close in proximity, they exchange random, rotating identifiers via Bluetooth. When a user tests positive for COVID, they can opt to upload their keys to a system called the key server. Other mobiles download the keys from the server and perform local matching. A matching generates an exposure notification. This design means that the server does not know which keys or how many matches occur. While all matching is actually done on the client, today I'm going to talk about how we implemented service level objectives to the server side to guarantee it would be reliable for users who needed to validate their codes and certificates after receiving an exposure notification. So first you need to understand how the information flows within all parts of the system. In this case, there are 4 patterns of interactions. 1. When there is a positive test result, the clinician authenticates themselves with the verification server and issues a code. 2. They then send the code to the user via SMS. 3. The user phone communicates with the verification server to authenticate the code and issue a certificate. The certificate is used to upload their temporary exposure keys to the key server. In this example, there are actually 4 different user journeys here, but I need to elect one critical user journeys, referred as CUJ, to be the one that we're actually going to be based our SLO on. In this case, the interaction number 3 in this picture is the one that we're going to be used for our case. This is critical because this is where the user is interacting with the verification server. So this user-facing service is critical to make sure that our system is reliable and available whenever the user needs it. So we understand how the information flows. Let's try to look at how the verification server architecture is. The system I described only shows the main information flow patterns, but in reality, most systems at scales have a broad surface of auxiliary functions that evolves over time, right? Exposure notifications is no different. You can see here on this list all different services on this microservice architecture. There are components that is being used by the system. I'm not going to dive into the system architecture details here, but in order to understand the reliability of a system, it's important to know the system architecture and its relying platforms. You see here that the system is actually using many Google Cloud Platform products like Cloud Scheduler, Memory Story, Secret Key Manager, and others. Our system's reliability depends directly on the system, on the products that we use as well. So we started with an availability and latency SLO for our application. Since this was our first attempt to define an SLO, we started with a default 99.5% target, 2.5 nines. We also decided to use the Google Cloud Load Balancer that have the HTTPS request count metric to count as the good interactions and the bad interactions based on HTTP response codes, where 500s are bad and 200s are positive, are good. We applied it to all the servers we have described in the previous slide and call it a day. Very easy, right? Well, not so much. As soon as we applied this to the system, we received 76 pages at once. Note that all of these alerts were actually sent into our paging system, so the person on call, myself, had to be manually hacking each and one of those all these pages. So what happens is that not all servers that we saw in the architecture was actually in the main request path to the application. So they didn't receive enough traffic. So one single 500 could actually trigger an SLO alert. And we also forgot to remove the 100 and 300 requests. And also some 400 application codes were actually mistakenly classified as 500s. So we went back to the architecture diagram and did the reverse engineering thinking from the CUJ. So when the user is actually interacting with the system, which service is the one that actually responsible for replying to those requests? And we found out that the server in this case is the one that I have highlighted in green here, the API server. So we removed the definition for all service and only work with the API service application here. We also removed the latency SLO definition from the service since all interactions were actually happening asynchronous in the user's device background. Instead, we implemented the threshold-based alerts for latency of all services responsible for the user interface. Here's in detail how we did it. We actually worked in Terraform to keep the infrastructure configuration information in code format as well. I hope you all have been using infrastructure as code because it's super cool. Here you can see in code the configuration of the SLO for availability and how we applied that to each service. I'm not going to cover in this presentation, but at Google, we have found that most of the outages are actually triggered by configuration changes. So it's critical that these definitions are in code where you can actually submit it for a code review and easily roll back if needed. We had a lot of trial and error before arriving at these conditions, and being able to get review for each trial was key. So here are the key lessons that we learned in this case. 1, know what matters to your users. We could have actually saved a lot of time if we had focused on the critical user journeys, thinking about the user interaction with the service instead of trying to understand the the entire architecture of the system. The second, consider the traffic patterns, that most of the system at scales can have very complex architectures, but if the traffic is not flowing all through them, you don't actually need to implement SLO to every single service. And third, consider the alert delivery. In our case, we only had the alert sending to our paging system, but after consideration, we were able to separate the high priority alerts to the paging system and the low priority alerts to our email system. I know that each use case is unique, and if you're not focused on your customers, you won't have a reliable system. Also, note that reliability is actually defined by the users, not by your monitoring system. Remember that I said that I work in the Google Cloud Platform support? I have never received a call from a user saying, hey, my system is up and running, it's great, thank you so much. If the system is calling you because their system is that depends on you is not responding, your system is not reliable, regardless of what your application says. So when defining SLOs for your system, you may be too focused on the nines and wondering how important it is to have 3 or 4 nines. But I invite you to take one step back and looking at the impact of your system in the real world. For example, in the exposure notifications project that is an open source, one implementation of it was done by the UK. And once they actually did a study to see how the impact of the application was in the community, they found out that for each 1% increase in app adoption, it led to 0.8% to 2.3% decrease in cases. This was only possible because the app was available and reliable when the users needed it. So I hope you have enjoyed this talk and learned how critical it is to have a way to measure the reliability of your system. If your system does not have an SLO yet, I want to remind you to follow these 4 steps to define it. By making sure your system is available to the users, you will allow them to use it to their best interest. Thank you so much. Here's the GitHub link to our repository for the exposure notifications application, and I'll be around for questions.